And I will pass it over to you, Maura.
Okay, and so thank you very much, Jennifer. It's appreciated you sponsoring this, and to help teachers get a little bit more adept at working with science is really a wonderful thing. The next generation science standards are not new. They've been around a long time, but they are probably still a matter of still our concern, because we're not all sure about exactly how to work with them, and the curriculum still being developed, using them in each of the districts and stuff like that. So we'll hear from that from you, if that's okay with everybody here, with our group here. My name is Maura Graham-Vecellio, and I am a 30-odd year teacher from Meriden. I've taught in Meriden all those years. I am an elementary school teacher. I also have taught at St. Joe's College at the Foundations of Education also. So I love science. I have, my background is environmental education, and I just, the hands-on part of science, I just could not give up. There are so many technological wonders that we can be using in services, but this one is kind of using the opposite, is taking the things that we could do at home, if we are, maybe distance learning, or doing things in your classroom practically and reasonably, because sometimes it's difficult to get things prepared, and being able to do it as simple as possible with good learning as the goal, and not to be too complicated with the whole structure and the implementation. So my background again is really with the union. They've provided wonderful opportunities for me with working with the next generation science standards really from the very beginning. And we've done a professional in-service in the Teach workshop that's held in Washington, D.C. And I'm on the NGSS cadre team of many teachers from all around the country that work together for different projects, including capstone projects for science and other things that it's just been my privilege to be a part of. So that's me, and I am going to lead you through a few different activities. This is a 4th and 5th grade in service, so that you can, if you are not that grade, if you were below or above, I think you might be able to find some something valuable, but you're going to make that decision accordingly. And since teachers are ingenious, I'm sure you will. So let's introduce ourselves in any way that you'd like, and maybe why you decided to sign up, and maybe where your district is in the NGSS process, if that's not too much to ask on a beautiful afternoon after work. Chris, would you mind starting?
I'm happy to. Thank you.
Okay.
My name is Chris Willems. I teach 9th grade science in New Haven Public Schools. I've been teaching there for almost 20 years. And I signed up for this because I do teach 9th grade. It's really not that far from 5th grade in my mind. I always learn so much when I interact with my elementary colleagues. And I've had such little interaction with colleagues this year for obvious reasons. I really miss it. We are pretty well along with, obviously we've adopted the NGSS standards. Personally, it's a challenge. I see myself as an inquiry teacher, with the old standards that we had, and NGSS is slightly different. I don't talk the talk, so I think this will help me to be able to better understand some of the underpinnings, and to be better able to put the practices and all the cross-cutting concepts, the whole core part of it into my practice. So thanks for the chance.
Very good. And I'm just going on my screen in a row by row. So Michelle, would you be kind enough to introduce yourself?
Sure, my name is Michelle Lorenz. I'm a 2nd year teacher. I have a master's in elementary education, and I got my 2nd master's in special education. I teach at EastCon in Columbia. I teach a mixed level class, 3rd through 6th. So our NGSS, I oversee someone who does teach my science lessons, but I have to be familiar with the standards at different levels and different grade levels in order to ensure that the kids are getting what they're supposed to be getting because of the law. But also it's really important because what happens is we have a lot of kids that come back year after year. They're with us. Some of them are with us for a couple months. Some are with us for 3 years, maybe longer. And so it's really important when you jump grades, like if you're third grade, you need to get your third grade standards in so that it builds. Because what I've been finding with NGSS is that they really build on each other. And if you don't have that prior knowledge, it's really not going to benefit you in the next grade. So that's my story.
Perfect. Thank you very much. Absolutely. And Chelsea? I'm sorry, Alessia? Is that how
That's
it's?
right. Hi, it's Alessia. Yes. I am a special education teacher at EastCon. I work in high school. I'm here to gonna get to learn and understand the idea behind this test. I do assist in administering this test on a high school level. However, I'm here to learn. I would like to know more about it because as I think Chris said that it's not too far from elementary education, 4th, 5th grade. All the I believe like science is kind of cumulative thing. You have to learn the basics and then move on up. So I do want to know more about this NGSS test so that I can help with students who have special needs in terms of what the elementals, what the basic needs they have in terms of science. So again, I'm here just kind of to listen in and to learn. I'm not a science teacher again, just special education, and I'm looking forward to getting to know more about it.
Thank you very much. Very good. And I have Matt, if you're here, or Mary, your video is not on, or
Just real quick, Matt is our communications director. So
okay.
he's not a science teacher.
I see him often.
He's here to learn.
Mary, would you like to say hi, or Mrs. Ray? They don't have video on, but if you're welcome to come on and say hello. Otherwise, we'll go ahead.
I can say hi.
That'd be great.
My name is Janelle Ray, and I teach 5th grade in Waterford. And the reason why I signed up for this is because we are looking for new and creative ways to have the students experience science this year. So we're looking forward to hearing what you have to say and to learn new ideas.
Thank you very much. Appreciate it. And Mary, just an opportunity if you'd like to say hello.
Hi, sure. I'm driving home right now.
Okay, thank you very much for coming.
Thank you. I teach 5th grade, back in 5th after a few years in 4th. So the last time I taught 5th was not this format. So I was looking to get some good information for my new 5th grade standards.
Okay, great. So thank you very much, everybody, for a little insight. It gives me a little bit of material to be able to gear what I'm saying really generally or specifically. And I applaud the people coming in just because you want to lay the foundation, and if are there any lags or if there's anything that previously wasn't taught, you can find this out by coming to something like in an elementary type professional development with the NGSS. Also, the science and engineering practices are the same throughout. It's a K through 12 career and college readiness program. So it's going to be a valuable, hopefully you'll have some more material that you'll just keep accumulating so you can feel a little bit versed in it, even though we've had the NGSS in our lives for a while. It really takes a while to get used to it, and it isn't an easy process. And I can say from the inception, I'm learning every day a little bit more. So we can talk about that a little bit. But so generally, the materials in this in service here are going to be actual tasks that are pretty simplified. You don't have the lesson plans, but you have the materials that you need and you have your objective, because this NGSS performance expectations that you read on the material that I sent out are not curriculum. They're just what you expect to see a child do, a student do eventually, not just after one lesson, but after quite a few different lessons. So how you get there are through the practices. And you're going to be making the decisions along that line. The lessons that you're choosing are going to get them to those performance expectations because you expect them to do these certain things. So it's a little bit different than what we've looked at before with just an objective. A performance expectation is like a long-term endeavor. It's an expectation over time. And how you get there is very, determined by your style, your curriculum, if it's even developed along those lines. If you look at the actual NGSS, which we're going to look at in a very brief video, it's only like a 5-minute video. I think it's going to be helpful to everybody. They're going to show you the format that you might have already seen, but I think every time we look at it in the format with the different colors and the three-dimensional analysis of it, it gives a little bit more insight into what exactly we're going to be discussing in the actual tasks. So I'm going to share my screen right now, and we're going to just see a very brief video. There's so many of them out there, but I like this one particularly because it's brief and it shows the next generation science standards and the page that you'd look on when you looked at whatever you wanted to study, the topic or the grade level expectations, etc. So I'm going to now share my screen, and we're going to be able to do that in just a moment. Just give me a second. And it's about 4 minutes, maybe 5. And I think it's valuable enough to start off. So I'm going to be sharing my screen now. And everybody can see in here.
Welcome to the NGSS overview. So NGSS stands for Next Generation Science Standards. They are national standards that have been adopted by the state of Connecticut, and they will, over the course of the next few years, be replacing the Connecticut teaching frameworks for science. So these are going to be the new standards, that's for sure. What is still not quite sure is exactly how it's going to translate into actual teaching practice. But for this class, we're going to only focus on NGSS because they are Connecticut's science standards. Again, they're just not clearly laid out per grade level like the Connecticut frameworks are right now. But they are within the NGSS, and that's what we'll see now. So to view the actual standards, there's a couple ways to do it. I'll show you my favorite way, but you should spend some time on this website, getting to know it, looking at the tools and resources, and learning about the standards themselves. All of that can be found from these tabs here. So to see the actual standards, we're going to start with search the standards where I am right now. I like to do it by DCI, which is disciplinary core idea. You can also search standards by topic. It's completely up to you. I'll show you an overview of both. The top one I would say is my favorite, disciplinary core idea. So you click on it. Then click elementary. And then here are your standards. For the most part, they are organized by grade. The letter and or number at the beginning usually corresponds to the grade level, but some do go across grade levels. Like you'll see this one right here. It's really for 3rd through 5th, but it's in the 4th grade column. So for the most part, the first number indicates the grade level. Now, your micro teaching topics that you picked last class correspond to these disciplinary core ideas. So for example, say your micro teaching topic was energy. You're going to need to go to this website where I am right now and find 2 standards, one for K2 and then the other for the 3 to 6. So K2 looks like here is my energy standard, and then I need one for the 3-6 lesson, and here it is. So you'll notice that it's only in 5th grade and kindergarten that I can see here. So NGSS is organized, oh, here it is in 4th grade too, I take that back. So you'll notice NGSS is kind of organized weirdly. I think they do that to spiral, the purpose being to come back to certain topics in different ways over the course of the early grades. But I recognize that it's not entirely intuitive. It's not exactly user-friendly. But this is the best that we can do with what we have as of right now. And there is a lot of funding going on right now to develop better PD materials as to how to use these resources, supported by the National Science Foundation. So for all the standards, no matter what grade or which one you choose, they all look the same. Obviously, the text about what it's about is different. So I'll click on this KPS3 energy as an example. So what this starts with, they don't necessarily, it's not a cut and dry summary. What these NGSS standards are basically tell you what the students should be able to do. So to show mastery of KPS3 energy, students need to be able to do these two things. They need to be able to make observations to determine the effect of sunlight on Earth's surface, specifically regarding sand, soil, rocks, and water. And then it clearly adds boundaries of what exactly should be known or assessed. And then they need to definitely be able to use tools and materials to design and build a structure that will reduce the warming effect of sunlight on an area. And again, a clarifying statement of exactly what this could look like. So, and you'll also see as I was scrolling over, pretty much everything is defined to help clear up what exactly they mean by these standards. So it's not just a student should know this, it's students should be able to do these things. And they specifically tell you how to do them. Down here, these are more or less the alignments to show you how it all comes together as part of the framework for K-12 science education. And then down here will be helpful to you. It shows you how this standard aligns to the Common Core standards. So in this class, we'll be using NGSS and Common Core for all the assignments that we do. And you won't have to go to the Common Core website and find different ones because they're all here, which is helpful. All right, I'll go back and I'll show you the other way to do it, which was by topic. Just a different way of looking at it. And again, I strongly recommend doing this on your own to see how you prefer. And here are the topics. So really just the same thing. Let's do another example. If your micro teaching was engineering, we already did a K2 one, so let's go for a 3-6 one. Engineering, you could do this one, 3 to 5, 3 to 5, 3 to 5. Well, I guess it's all the same. So let's just click this one. And again, they look the same. They tell you exactly what the student should be able to do to show mastery of this. Shows you how it's aligned. And then shows you how it connects to Common Core. So they all look the same, they have the same information. I realize that it is a little bit confusing to a certain degree. It is just a matter of clicking through and finding what relates. But this is where Connecticut will be within the next few years. And good luck. Please email me anytime or stay after
All right,
class.
so I'm going to stop the sharing, right? I'm going to stop that now and go back to where we were. So you see that, have all of you already seen something similar to that before? And you've looked at that because you were gearing yourself to a certain topic area. So all of those areas that you looked at, it's all color coded, so it's supposed to simplify. She said this was a little hard to read, and I think it might be to somebody who's first looking at it, and I'm not sure where all of you are. Do you have any feedback as to tell me how you feel about looking at that first page, or how you've done before looking at it when you've had to look? Because I know I hear this special ed teachers have to do different grade levels. So did you have to look at those kinds of topics or anything? If you want to, yeah.
Yeah. And usually when it comes third through fifth, it's a little bit tricky because especially when you're cycling around. I'm sorry, I have a cranky baby. But it's a little tricky with the balance and redundancy, I think. And I think that's what a lot of instructors and teachers are facing.
Yes.
Is how to teach something and then teach it again in the next grade. Because it's all about growth. And so you see a standard and it might seem like it's the same standard, but it's not the same standard. It's the same standard. It's not the same skill you're necessarily teaching.
Yeah.
And I think that's where the difficulty comes into play as to how. So I guess really what I'm looking for out of all of this is maybe suggestions for like lesson building or curriculums, or I know Next Gen does have something like that, right? In there too.
Yeah, absolutely. Anybody else have anything to say about just looking at that whole the page, or if you've had some experience doing it or not?
I've tried, and I sort of have an allergic reaction to it. I just get completely overwhelmed. It's got so much. I understand the conceptual underpinning,
Yeah.
but I can't use it. And I work from other documents and other bits of information just because it makes me crazy.
Yeah, I understand that completely. And I'm purposely giving you time to vent because that is a very common experience for teachers. And especially because she said, it'll tell you exactly how to do that. And that is not true. It will not tell you exactly how to do that. That was not right. And some of these things you'll see on YouTube, et cetera, are telling you what you're supposed to be doing. And that is really not the case. The NGSS is only a guideline for curriculum. Your grade levels and your districts should be providing curriculums and lessons. They probably aren't. They hopefully are. They probably aren't. And that's probably why you're here, looking for some things to get to cover what you want to cover for them. And all of them are not spiraling. They are not spiraled 3 to 4, 4 to 5, the same topic at all. They are sometimes not seen in grade 2 and then seen again in grade 4 and 5, or starting in kindergarten and then jump to 3rd and then 4th, and then not seen again in 5th and then on to 7th, etc. Eventually, over the time of K through 12, they are supposed to be cohesively covered. And that was really done purposefully. And it was done really methodically and with a lot of thoroughness. So they believe that this is really done well, but it's very hard to see it if we're in our grade level or in a few grade levels and not seeing the same topic, right? So Alessia, did you have something to say?
No, just I'm listening in. No, nothing.
Because you're a special ed teacher, I know that you'd have to look up the topic or what you were studying. So that might be helpful if you haven't ever done it that way. The document online, the best website, in my opinion, and I would recommend it, is the NGSS Hub. And it's called the NGSS Hub. And if you just Google that, it's going to bring you to that nice color-coded thing, and you can, we are organized as teachers. We're able to organize. Oh, I want to do it by topic. I want to do it by grade level. And you will if you're in your particular cases. If you want to see what's done the years before, as a high school teacher, you'd be able to do that by looking below your high school area. And once it gets in high school, it's very networky. They have certain networks that you're going to go through, which is pathways is what they call them. They're not, that wasn't really shown well in that particular short snippet, but it is at least helpful to understand. So the DCIs, they talk about DCIs, and this is talking the talk. So we're going to talk the talk, okay? So DCIs are disciplinary core ideas. And it's a big, the big word for the categories of science that all of the things fall under. Life science is LS. So if you're looking at a topic on that page and you see LS, it's life science. So that's one of the core sections of science that things fall underneath. Physical science, PS, would be another one. So you'd see that in the beginning of that performance expectation or that page that you'd be looking for, and you'd know that's under. And if this is repetitive or simplified, it's still something that maybe somebody doesn't necessarily know, so I'm going to just cover it quick. ES would be Earth and Space Science. So ESS is Earth and Space Science, and a lot of things go under that particular umbrella. And then there's the ETS, which is the Engineering, Technology, and Applied Science. So these are the LS, PS, ES, ETS prefixes that you see on all of those performance expectations. And those are the disciplinary core ideas. So when you think of the core, you think of the main umbrellas that all the different concepts of science are going to fall underneath. The common core, the CCCs, the common cross-cutting concepts are big, giant, broad links. So they're like a link that are going to be able to put some of the concepts together. They're going to link them in particular because they're something like the patterns. So you might look for patterns, and there might be patterns in life science, there might be patterns in earth science. Obviously, an astrological year, the things repeat. So there's patterns in a science. In life science, there's going to be a cycle of some kind that repeats over and over. So that is the general link that can put the concepts together. Cause and effect, the similarities and differences. So that's what the cross-cutting concepts are. So when you looked at the page and you saw that 3 columned sections, the DCIs would be one, the cross-cutting concepts is the other. And the last one, which is what we're really going to talk about today, is the science and engineering practices. And that's what you have if you were able to get that off the internet. And if you're not, it's okay. What you can do, if you have a piece of paper and pencil, if you have that paper, it should look like this. And it's a columned, sectioned paper that has each of the science and engineering practices, actually 6 of them. And there's actually 8 of them all together, but we're going to definitely be using those other 2 practices, and I'm telling you straight out, we're going to use the other 2 practices. So if you ever would to write something down or chalk it off in your head, we are going to engage in argument. We're going to see how the activity works or doesn't work for us, a given concept. And then we're going to be obtaining and evaluating and communicating information. So those are 2 practices that most of the time, if you're talking, if you're doing any speaking and listening, you're going to be working with those particular practices. All the practices are not going to be done every single time you do a science lesson. Some of them lend themselves better to certain lessons than others. In fact, if you did use every single one, it would be a really complicated lesson. And we don't like things too complicated, and students don't usually either. We like to have things simple. So you want to, a lot of times the approach that teachers did it initially were to think, what practice am I going to use? What do I want them, the students, to get better at? Do I want them to get better at asking questions? And that's what we're going to do right now. We're going to have you be the student, or, just a walkthrough. You're not going to have to be put on the spot, but you be the walkthrough person as if you were the student of something, and you're going to come up with some questions for a situation that I'm going to show you. And so that's one of the things that we're teaching the students to do. They're going to be the scientists. They're going to be doing those practices, and therefore they're doing the science. And it could be under any concept. These same practices want to be seen. Again, not all at once necessarily. Today, the last 2 that are listed in the practices, probably everywhere that you look under the next generation science standards. I have a poster over here. I don't know if you can read it, but there's the old school poster. There it is. The bottom one is engaging in argument and obtaining and evaluating and communicating. Those 2, the ones on the bottom, I did not write down on this chart because I'm telling you right now, we're going to do them. But you are charged, if you have this paper or if you don't, you're going to write down on a piece of paper, just quick 1, 2, 3, 4, 5, and 6. Just write down those numbers. And I'm going to ask you, when we do the activity, if you think those practices would be done by the student. So we're gonna get practice at determining the practice that can be done by the activity. Does that make sense? Okay, so the first thing that we're going to do then is no, today we're mostly working with the science and engineering practices and being able to determine which one is going to work for that task. And so I know I reiterated the same thing, but I wanted you to know that that's the goal or that's the charge. And if you leave that knowing a little bit more about the practices, then you can lend that to your students, and you could be doing the actual science on any concept with any lesson. So you can get a lesson that you might have gotten from Share My Lessons, which have great lessons. And I would highly recommend you to be looking at one. And we will later today look at one called the Roller Coaster Lab. And those lessons are wonderful. The National Science Foundation also has wonderful lessons with science. So as you're choosing the lessons that'll meet the performance expectation, because that's the first thing you saw on that page. The performance expectation is also what I sent to you on the handouts. The performance expectation is what you want the student to be able to do, not just in this one lesson, remember, over time with a number of lessons. So you're going to start to think, if I show you this lesson, what did we have to do before? What might I do later to get them to know it a little bit more? It's just a snippet, not the lesson that'll get you to do that. I don't want that to be clear, okay? So right now, I think that you're going to be able to see what I'm doing. I'm going to give you the speaker view so I can see what you see. Are you going to be able to see my table? Would you give me the thumbs up if you could see my table?
We can see it.
Okay, thank you very much for telling me. And so right now I have two plates, and these plates are going to become a model. They're a model of a grade 4 expectation, which has to do with energy and with the earth systems. The earth systems. So we're going to be making observations and or measurements to provide evidence of the effect of weathering or erosion by water, ice, wind, or vegetation. That's the actual performance expectation written. And you have that, if you have the papers that were sent to you, you have that there. It's for ESS, which is Earth Science, Earth and Space Science, right? And the Earth Systems, and -1, because there's sometimes -2, 3, 4 different number in that particular category. And so weathering. So if you see what I have here, I have a glacier, a model of a glacier. This is ice chips. And I do have some soil, which would be, and I do have a rock. That's just a model of what might be located out there. Now, you know that we're talking about a model, so it's not the real world, but it is a representation that might be indicative of some place. Now, can you think of a place that would be a possible thing you would see in an outdoor large area? You can picture a space in the geography of the world where that might be. Yes, thumbs up if you do. Okay, and then the other one here, I just have soil and I have lots of rock. And it's
Maura?
Yep.
I'm sorry to interrupt, but could you tilt your screen just a little? We can see the other way. There we go.
There
Perfect.
we go. Thank you very much. I appreciate that. It's hard to see while I'm looking too. Thank you. So again, the simple is better. So these are materials, and you had a materials list. And if you don't have the materials with you, and if you are choosing not to do them or to do them, they're simple materials, hopefully, that everybody can get at easily and not too expensive. And they're valuable because they're going to have kids do it. Even if you're demoing it, you're actually doing it. If you could have each of the children doing it at their own, if it's distance learning, could they be prepared with those things? Could they have gone outside and got these things in an assignment previously? Or could you have provided this in a controlled situation in the classroom? Or can you do one of these particular models in a group if you were doing group work, whenever we get to do that in our lives back when the world becomes normal again? So what I'm going to do is I am going to think about what could happen in this environment. I'm going to use water right now, which could be many different things. I could be sprinkling the water. I could be using a spray bottle for just it being a light rain. But today I'm going to make it a flood because I want it to be dramatic. So I want you to think about a question you might have. If I used water on these models, what do you suppose would happen? So I'm not asking you to tell me what happened. I'm asking you to come up with a question. What question do you have if I used water on these models? What kind of a question might you come up with? And if anybody could just say it out loud, that would be great. No question?
How would the ice and water be different from just the water and the soil and the rocks?
So you're already touching on, a similarity and difference just with your question, which is one of the cross-cutting concepts. Maybe you're the kind of a person that likes to compare things like that. And that's already something that is, a broad link between any kind of science. So that's a great question. Anybody else have a different question? Think like a kid. What other question would it be? Well, you can think as simple or as complicated as whatever. One more question.
Maybe, will the ice melt?
Great, exactly. And so what you might do is you might brainstorm questions about something, and they're like, waiting with bated breath, even though it's not so something, because they just want to see what happens on the model, but they're also considering the actual geographical components. So they might have had some background before this, and this might be in the middle of a lesson, or it could be a cumulative type thing. It could be one done in the very beginning, it could be to see. So I'm going to I probably would do a spray bottle, and then I would do an eyedropper, and then I would do a little cup, but I'm going right for the gold. I'm going with the dumping of the water, which is always fun. And we're going to flood it. Okay, so there's going to be a flood. There's going to be a torrential downpour of rain that is going to be coming. And I'm going to do it first on the model of the soil and the rock, which might be a mountainous region of some kind. And it's coming from a waterfall. The drainage is clearly going a certain direction, and I don't know if it's easy to see or not, but when I had the water in this particular regard, which was where the water might be, maybe a drain might be draining, the water went this way instead of that way. And so you'd have to take that observation and make your determination of what would happen in the real world, and why would that be a problem or not a problem? Or did this happen? Is it what you had expected to happen, or was it different? I'm going to do the same thing on the ice. I'm going to do it from the same angle. So this would be say a drainage that the flood was coming because the water was not going to be able to be gone by the other means. So it's going to go above the ice, which might be a glacier, it might be a pond, and it might also, we have something dramatic happening there, which is, again, something that is a good, observable, simple kind of science thing for them to look at. So this is something just basically called, it's erosion, because it's happening right here. There's no change or decomposition of the material. So it's not weathering, it's erosion, because something made a change and there was movement. So you're going to have to know those two topics and the difference between the weathering and erosion in order for you to explain it. So the teacher who's teaching the science and doing the science has to have some background in what will come up from the student. But certainly, let's see, you're sharing your screen? Super. Nice. You're going to do the squirt bottle? Great. And if you're doing one on one, do the same time on the other, because we want it to be a comparative study. And can you explain, Chris, what exactly happened?
I've got some melting ice in here. I've got a nice mud pie going on at the moment.
Was there any kind of indentation of any kind from the flood. It didn't look like, yours might not have been a flood because it looked like it was a little bit more sprinkled, and so I'd ask, what was the weather condition that might represent? Oh, yeah, and again, does it have to be a flood? No, it doesn't have to be. It could be anything. It's just that it could be just a spray bottle. It could have been just drops. But what happened to the particular experience that was going to change? Again,
A lot of movement of the dirt. I see some of the rocks got clean. The
Yeah.
ice got clean.
okay, so there was something in the ice and now it changed. So the particles, again, that's going to be the erosion versus the weathering. Weathering is going to make a change in the actual material itself, and that's usually over time. But again, it's pretty simple, not too difficult, not too difficult to use. I wouldn't just use it once though. I'd take it over time. It might just leave it out for the next day and the next day and the next day, because things will change. That water won't possibly be there the next time. They might have a completely different, the evaporation might happen or something might happen, and you'll ask the kids, what happened to the water? And, did Mr. Chris, did he take the water out, or what happened to it? And those are the kinds of questions that happen. So simple, not complicated, and a really good model. So our charge today is to be able to know what practice we might use if we were doing something similar to that. I'm explaining that was the performance expectation was making observations, which clearly we were, to provide evidence of the effect of weathering or the rate of erosion by water, ice, wind, or vegetation. So we just did water, right? And erosion by water, because the water was the actor in this particular case, even though it acted upon the ice. If we wanted to do wind, we could have other issues. A straw in a controlled environment is also something you can simulate wind. A blow dryer works really interestingly, but you have to know what you're doing, because it wouldn't just be in a paper plate. It would probably have to be in a tub, which is what I've done before. And you want to just not make it up. It's not a blow dryer. It's a hurricane or a tornado. It's not just the straw. What would that be represented? And so that's a particular practice we just did. And so in order for you to recognize those patterns, we have that category, that chart, obviously. If you have it in front of you, great. If not, you have written down 1 through 6. And if you think that this practice was done, just put a check near that number, okay? So asking questions. If you think so, you would put a check after that, because that was a practice, and that lends itself often to different tasks, not always, but often, right? Developing and using models. And planning, and I'm gonna ask after we're done with the 6 for people to explain their choices, okay? Planning and carrying out investigations. That's number 3. Analyzing and interpreting data. Using math thinking. And the 6th one would be constructing an explanation for what was happening. If it was engineering, it would be designing a solution, but that wasn't an engineering task, so it wouldn't be that particular practice. So there's a few that are better than the others. Some really don't make too much sense for that. And there is nothing right or wrong. If you can rationalize it, it's right. So don't feel that you're doing anything incorrect. You just have to have a purpose for what you're doing. So I explained that engaging in argument was going to be one of the practices we're going to do on every single thing. So I can see where engaging in argument would work on that. Obtaining and evaluating and communicating information by making our descriptions and being able to talk about what we saw is using those 2 practices, even if it's mildly. I mean, So I'm saying clearly those I'm going to just like negate and say that there is some of that. It might not be too strong, but the others, what do you think? So how about Michelle, what would you like to say?
I thought that everything was met, except for the one thing I really kind of had a question about was using the math thinking. And that's the only reason.
I don't think there was a lot of math thinking at all.
I mean,
think
more or less, but it wasn't like the grade level math thinking. So
True.
is that like, what kind of mathematical thinking are we aiming for?
Well, remember, and this is important to remember, you will not have all these practices in every single lesson. This particular task, this does not lend itself to, true and exact grade level mathematics. Comparative measure always, which is always good to practice, but not in a large regard, unless you made it that way. This team do 5 drops. This team do 12 drops. This team do 2 cups. This team do the liter bottle of water and compare. That might be adding a little more mathematical thinking in it, but this one that we just did now really didn't have it. So it's okay. There's nothing wrong with that. How about analyzing and interpret data? Do you think that was qualified here?
Maybe not data, like as in like traditional data, but I think you definitely were analyzing things happening. And that was through the discussion and the questions, because they had to look and compare 2 different models together.
Absolutely, absolutely. And that's why those practices, to clarify those practices, data is data. Data is numbers, data is charts, data is routine. Data might be one day, the amount of water done, was it there the next day? And you could measure something measured, data is specific. So maybe that's not going to be one that you're going to be having too much clear data, but are you evaluating and communicating an idea and determining, comparative measure? Yeah, absolutely. Unless somebody disagrees. What do you think, Chris?
All I was going to say is it's descriptive data. There may not be numbers, but you got the quality of the environment that's changed, and those are data.
I'm so glad you're bringing that word quality up, because often in the elementary standards, there's an assessment boundary in the performance expectation, and it's almost always qualitative, not quantitative, until after 5th grade, because they need the math to be able to produce that really well. So that's a really important thing to look at when you're looking at the performance expectations for the other participants in elementary school, because you don't want to go too far. You want to go just far enough to lay the foundation, because Chris is going to take care of the rest when they get up to high school. Right? So, I mean, or middle school grades, etc. All right. Or if you're going to see them again in the next year, like Michelle has in her circumstance, where you might see them again the next year, or a different year, or a few years in a row.
I think that's the challenging part, though, is because everything has been grouped. So like this is 3rd through 5th, and then you get 6th through 8th. But what happens when you have 6th graders mixed in with your 3rd through 5th?
Yep.
And that's the balance. That's the tricky part, I think.
It is a tricky part, especially because you're probably looked at with your supervisor to be able to cover everything you need to cover, etc. But in the big scheme of things, if you were getting them ready for a CAP test, and you were doing any kind of an investigation, and you were using some of these practices, you're doing good science. You're doing science that they can use in another respect, in another situation that's given to them in their actual testing instrument. So okay. That's the optimistic view.
No, that's
I'm trying.
I like it. I'll take it.
So we're going to go on to another 4th grade situation, and I'm just gonna, while I'm talking, I'm going to get this ready. This is, if you have the documents that we sent to you, we are going to still use the same chart with the practices on it, or with the 1 through 6. If you have just that, that's fine, because you're going to see all of those practices might not be in every one of the tasks, but you are now becoming more adept at understanding the practices because you decide, oh, that really lends itself to asking questions, but not so much with using data, except by numerical data, but certainly just descriptive data. The modeling there was used very strongly, don't you agree? That was a model. I mean, what was it a model of? That the questioning and the developing models, how did we work together there? Because you wouldn't just put everything anywhere just together. Like, what would it simulate in the real world? Where in the geography of the world would there be big boulders and a little bit of soil on top, and then water coming above that? You know, I mean, you have to consider your model. You can't just randomly, obviously, put things together. This next task is going to have to do with fourth grade. It has to do with energy. And the performance expectation, as you can read on the paper if you have it, but if you do not, I will. It says, make observations to provide evidence to show energy can be transferred from place to place by sound, light, heat, and or electric currents. So this again is a simple activity. It's kind of, I really like this activity. I did this with my kids before. I'm going to ask you if this is visible. It doesn't really have to be too visible. I'm actually just using, I'm going to sign in, I'm using my Chromebook to be able to provide some music for us. And I'm going to get some seriously, it's not too loud, but it's going to be, well, you hear it. I'm going to also see that it's attached. If you can see, it's attached to a speaker. And if I'm lucky, it's going to turn on. So the speaker, I hope it's working.
Instead,
excellent. I have to skip the ads. Excuse me. There we go. All right. So I'm just going to have you listen to some tunes for a minute. So this is upbeat instrumental work music. It's just from YouTube. I have my Chromebook attached to a speaker, one of those mobile speakers that my adult son has. And it's a really nice tool. Every tool won't work this way. So you have to be careful about it, because like a phone, the speaker on a phone is not going to work as well as something like this that has a little bit more amplification. But we're going to try to provide evidence that there's energy transferred here today. So I have all these materials that I have in my hands, and I'm going to ask you to listen carefully to see if there is a change in what you hear. So you can even close your eyes if you want to, or you can keep your eyes open. It's up to you, because you can't feel it. I can explain my feeling, but if you have the materials, it's an excellent tactile experiment. I'm going to take a few different materials. I have a clear piece of laminate. I have a piece of tissue paper. I have a piece of felt and a few other various things. Cardboard I'm going to use too. I have cloth, etc., but I'm not going to go nuts there, but I'm going to put it on. I'm going to ask you to listen to the sound, and then I'm going to put something over it. I'm going to ask you to see if you see if there's a change in what you hear. Thumbs up if you hear a change. Okay, I'm going to ask you to consider that, and I'm going to change the item that I'm going to cover, because I hear the sound coming from here. It's not coming from anywhere else. If you were here, you would know, or if you had it in front of you, you would see the sound comes from there, but I don't see what the sound is. But I do want to provide evidence that some energy is being exchanged from the speaker to my ears somehow. And I'm going to provide evidence. You're going to provide evidence by explaining what you think is happening. Okay? Let's try again. Oh no.
Grammarly helps make your writing clear and
Another
concise,
ad.
no matter where
Too
you
many
are.
ads.
Compose a cover.
Sorry about that. Okay, different kind of music, but and I'm taking it off. And I'm putting it back on. And I'm going to go back to the other material. And off. And I'm going to stop. Okay. So I would like some describers. Will there be somebody tell me what they're hearing? Can you explain what you were hearing?
I don't hear very much of a difference with the
Okay.
green fabric.
With the green fabric. When it was with the other material, did you hear a difference?
I couldn't really tell. I'm going to be honest
And
because
that's what you're supposed to be. You're
the
supposed to be
the
honest.
music was a little choppy.
Yep.
Like, so I couldn't tell a difference. Like before I could, because the music was constant.
Yep. I understand that completely. Anybody else?
Yeah, maybe because the music was like high pitch, the chirping of the birds, it's such a high pitch. Maybe that's what affected the.
So sorry, I didn't mean to interrupt. Sorry.
It's so fine.
So I'm going to go back to that first bit of music, and I'm going to do the same thing again, just with that same music. Okay. I'm changing. And I'm going to change one more time. Okay. So the kind of music is really important to be able to do. You're right, absolutely. The drum beats are, the bass is really big, so the music is, I'm trying not to use science words. I'm trying not to use them. Can you imagine? I'm trying to talk like a kid would do. I can't do it. It's inside my head and I can't help it. But, so you explained to me what you see as the three different materials were put on that with that base, what you heard this time. Alessia.
Heard, oh.
Alessia, would you mind trying to explain?
Sure. This third time, certainly, the difference was noticeable. The sound were subdued, not as bright or vibrant, I would say, when it was covered. When it comes to covering with fabric, very slight difference, almost none whatsoever, very light, if any.
Yep.
But when it comes to thicker surface, that cardboard certainly made the change.
So why do you think there was a change? Why do you think, if we're trying to provide evidence to support the fact that energy is exchanged, how can you use that experience to do so?
Well, it seems like different kind of fabric absorbs the waves. I'm not a scientist, so I'm trying to.
But you're using the science words, and kids might know those words too. Kids might know those words.
So yeah, I guess The fabric, because it's airy, it lets the air out, and the waves would pass through it. So that's why it didn't.
So we can't see the energy, but we can provide evidence to support that something was transferred from the speaker to the air or to our ears somehow. So you get the picture, you get the idea, right? So we don't have to go through the entire experiment through 100% to be able to get the idea of what we're after with the kids. So let's go right over to the practices. Do you think you were asking questions? Do you think you were developing and using a model? Were you planning out and carrying out investigations? Were you analyzing and interpreting data? Using math thinking? Or constructing an explanation? If there was any one that was strongest, what would you say it was? Chris, we haven't heard from you yet.
I would say the planning and carrying out an investigation would be one of the stronger ones, simply because we were using different materials and trying to see how they interacted with the sound.
Can you see how a kid would really, a student would really enjoy that kind of a thing? The blocking of the sound. And when you have your hands on it, it is dramatically different on the material itself. It's a really fun activity, and they can come up with good ideas too, to have this investigation. And they have a job. They have to provide the evidence to support that. So there's so many things to do. We just got through the two fourth grade ones. So we are going to now go to a fifth grade activity, which is really quick. And we're going to do the same thing with the different practices. This is a very simple activity. It is done with a water bottle, and it has to be a certain cheap water bottle, not the good ones that like high C, or some of them don't work. It has to be inexpensive, thin material. You're going to cut it in half. You might have seen this before. It's easy to do with scissors. It's very simple to do. It's not hard because you can use the regular scissors. Certain age kids would be able to do it, or you can prepare that for them. You're going to have gravel. This is the gravel. That's the bottom. So we're trying to replicate, we are replicating the layers of the geosphere. All right, in a primitive way. I have some more part of another layer of our geosphere, and I'm going to put that in there. And I'm going to put quite a bit of it, because I'm going to also have some materials, a biosphere. I'm going to simulate a biosphere, taking inexpensive plants that you could get at the Home Depot, really inexpensive, and just take them apart. And I'm going to put this inside to replicate that. Part of the living thing that's inside this land. All right. I'm going to be able to put this on top eventually. You can see where I'm going with it, I think. I am going to take my tape and I'm going to close this forever. I am not going to ever open this again, because I am going to be simulating something that happens on this earth at all times. In the biosphere, we have, the different, we have the biosphere that has the plants, we have the air, the stratosphere that has the air, and I'm going to put some hydrosphere property, which is some water inside, but I'm going to just water it just a little, and I'm going to keep it that way, and I'm going to see what happens over time, over quite a long time. Actually, I'm going to probably keep it all year. So I'm trying to do it as I'm fumbling through it. I'm trying to put the first piece in the second piece. That's the hardest part of this. Once you get that, you can blow it open and you can see that this gets topped. I'm going to take some more tape. It's the water cycle. It's a terrarium. It's a homemade terrarium, as you can see, and it's a model that is a really good model because you don't have to do one thing to this for a long time. And, you know, you would have predictions. You can see if what you think the kids think that the plant is going to be alive, if it's going to be staying alive, if it's not going to be alive. Why is it going to stay alive? What's going to happen to the water that is inside of it? Why did I close the system? What does that represent? You can see all the questions I'm formulating in a quick way because of time. And that is one of the very simple activity that is a great activity to do for kids using that performance expectation, which is to have, here we are. We're going to have plan and carry out tests to identify aspects of a model, right? And you're going to be able to notice that the water cycle here is really a 5th grade kind of a thing. Develop and use a model to describe the ways of the geosphere and how the biosphere, hydrosphere, and other atmospheres interact is the actual wording. So that's the water cycle in grade 5. And so let's go with the practices here quickly, all right? Were you asking questions? Were you using a model? Were you carrying out an investigation? Did you analyze and interpret data? Still not too strong on that, right? Mathematical thinking, not so much. Constructing and explaining an explanation for what's happening. So you see some are stronger than others of this particular activity, but all of them are not going to be particularly done. And I'm looking at the time and it's close to the 15 mark. I'm going to take another 5 minutes. Is that okay? Because I know it's about that time. We have a couple other simple activities, and I think you get the idea of the questions. I think you understand the questions that we're getting at. And I think you also, hopefully, after we've done these tasks, are seeing how simple some of these things are, but how they promote good thinking. So I'm going to use another simple activity. This is a grade 5 Earth and Space Science activity. It's also with the group of the materials that I set out to you. It says, reveal patterns of daily changes in the length and direction of shadows, day and night, and the seasonal appearance of some stars in the night sky. Now that's a lot, and this is not as in depth, but I'm using a paper plate, I'm using a marker, and I'm using a light source. And I'm using the light source that's blinking there. So I'm asking you to look at the marker that I just put in the middle, and you noticed that there is a shadow, and I have to have a light source in order to have a shadow. So that's the preliminary information that has to happen. Without the light source, there's still a shadow because it's that light source. But if there was no light, there would not be a shadow. Therefore, that is directly related. And so the movement of a dollar store flashlight can represent a lot of different things. And I'm moving my flashlight in an arc from one end to the other. And it's just a nice, easy and radical and dramatic thing for them to be able to see how the shadow is affected by the light. And there's so many implications for this all the way up to high school, definitely. In fact, it's a complicated concept overall. You know, why is the shadow so short when it's above, completely above it at the mark at the apex of the actual arc? And what time would it be? And when would they ever use something like this? We usually tell time by watches and stuff, but how did they do it before that? And you can see the implications of the simple activity. If I'm moving this way with my model, when would this ever be pertinent in the real world? Why would this be more sensible to replicate something in the real world? And so you can see the complications that you can address as it goes along. Do you get the idea? Yep. And I don't know if this is a simple thing that you have never thought of or something you have thought of and is too simple, but I think that some of these activities can be done just for the sake of doing a concept for one time, but they can also be studied over time. And that's why I chose these activities specifically. All right. Again, I'm getting to, there's always not enough time, but I think that we did 4 activities. You want to end with one great activity. So I missed one of the ones that I said because of time. This is a 5th grade also, and this is a great demonstration of what they call phenomenon, which is really big in science these days. And I would recommend, besides the NGSS hub, which I'm trying to provide the summary at the same time as the experiment, I want you to know that the NGSS hub is a great tool for the next generation science standards, and also the NGSS phenomenon site is an excellent resource for phenomenon, where you show the child, the students in the group or your class on distance learning a particular phenomenon. And I have one to show you, but time is not going to allow it. So you have to go on it yourself. They're really cool things that are just amazing things. And then you try to investigate what's happening in it. What I'm doing now is I'm putting yeast inside warm water. And let's see if this works, because if it does, it's going to come out great. It has to be warm water, and it stayed warm this whole time because it was in a thermos. Can you see what I'm doing? I have hydrogen peroxide. It's something called elephant's toothpaste. Did you ever hear of it before? Did you ever do elephant's toothpaste? Yeah, you have. So you understand it. I don't want to bore you with it then, but it is kind of fun. It's supposed to be about a 1/2 cup. I'm going to guesstimate because I'm pretty good at it, of hydrogen peroxide. It's not necessary to do anything from the from a hairdresser. The 3% is perfectly fine to do. You put the hydrogen peroxide in. You put
Or
in
can you tip your camera up a little bit? We can't see the top.
Thank you so much for telling me that. What I
It's the
see,
most important part.
are you seeing it? Yeah.
Up a little bit more.
Up.
Yeah.
There we go. Yeah. So a couple drops we're going to do. And again, I'm not even measuring, and I should be, because then if I was measuring, then we would be using math thinking, see? But I'm not because of time. So I'm doing a couple of the drops of the soap. And then if we're lucky, and I mix this enough, it's going to be elephant's toothpaste. Why they call it elephant's toothpaste, I have no idea. I really don't have any idea, but it's a chemical reaction, and it actually provides heat. That's not working so far, or is it? Yes, it is. Imagine, ta-da. It's like the hydrogen peroxide of baking soda volcano, but it's even more interesting because it's an exothermic reaction, and actually it's not going to hurt anybody because it's soap, and it's going to be a mess, but you're going to put it in a big thing, and luckily I can have that mess here. If you feel the foam, it's actually warm. So it's a really nice indicator for the 5th grade idea of chemical equation, chemical reactions and matter and so forth. So I'm going to end with that particular exercise, and I hope to do this again and show you anything more. I hope that it was valuable and that you're thinking about the practices and how you can have some of those practices in any kind of lesson that you do, but understanding you won't have all of them, but you'll have some of them, and you'll be doing good science. Is there any questions or anything that I can answer as this continually foams? It smells really good too, because it smells like the dish. So the heat is the coolest part though. Does anybody have anything that they would like to add or suggest for another time besides me taking too long talking and doing 2 more activities?
I thought you did great, Maura, and I feel so bad for your desk.
It's good. It's good. I have a tarp underneath it. Or you don't think I'm used to this? Oh my God, making a mess is one of my favorite things. No problem. And it's a tablecloth, it's no problem. It's just a really cool reaction. And it's, you know, this is what they would use as an example of phenomenon. You could do this before, like I'm going to show you something. Let's take a look, and then you can explain it after. But this is a really good indication of phenomenon, and it engages students right away. And it's really big in science where you don't do it just to do it. You do it so that they can investigate why and how and get a lot of background, you know, with the actual phenomenon, giving them the opportunity to think, which is what we're supposed to be doing in science every day. So anybody would like to say anything?
I would just add, I mean, this has been awesome. This has been very helpful. You've really unpacked a lot of stuff for me and really helped me to think through this. And, you know, and the elephant toothpaste, that's, you know, if you have enough hydrogen peroxide and yeast in warm water, kids could do that multiple times, which makes it science. And they could take the temperature, they could try different amounts of soap, they could really explore with it, and then look at the evidence that comes out of it. You know, if you've got the space in your curriculum or your day to be able to allow children to design different experiments, you're again really supporting the practices, right?
You are, and you're preparing them for good science, which is exactly right. The lab that I did not do, which I regret, but is the roller coaster lab, which you can go on Share My Lesson. That's the plug. Share My Lesson. And basically, you're using all kind of recycled materials, and you're making a roller coaster. And that's a good measurement type thing. That would be the indicator, because if I had done that one, I would have met a couple of all of the practices, because sometimes you do and sometimes you don't. But those particular labs are great so that you're able to do the trials, because that's good science, doing it not just once, but more than once, as you clearly indicated. And that's a really important part. And taking measurements and all that kind of thing, which you can gear your instruction towards if you know the practices you're after. So you can make the same task different by using the different practice in your implementation. Thank you very much for coming. Please come again when we provide these in services, and I hope that it was helpful. And I am available for anybody to ask any kind of questions, or just contact me because you love science. It's my name is Maura M. Graham-Vecellio at Meriden K-12 in the Meriden system. Look up Graham-Vecellio. You can't miss me. I'm the only one. It's a hyphenated name, but it's long, Graham-Vecellio. And I'd be happy to hear from you for any reason at all. And thank you, Jennifer, for providing this opportunity. I appreciate it.
Thank you, Maura. This was absolutely wonderful. Again, so interactive and so fun to watch. You know, we lose so much when we do PD virtually, but I can, you know, feel the bubbles all over my desk. So thank you so much. This was spectacular. You were wonderful.
Thank you very much. Thanks a lot, Michelle and Alessia. And it was a pleasure to see you. Thank you, Chris, for your interjections too. Appreciate it.
Have a good night, everyone.
Bye-bye now. Enjoy.